I mentioned before, engineering operations role is to provide the services, programs, initiatives to help engineering. But the thing is, right, depending on whom you're helping, those challenges and solutions will look wildly different. At Iterable, we categorize our customers into 3 categories, right? Our directors plus, which is kind of our directors, senior directors, VPs, CTOs, etc. Our mid category, which are managers, our people managers, and lastly, our engineers, our ICs. And each of our customers, each of these categories have very, very different requirements, challenges to efficiency and effectiveness. For example, our directors, right? They really care about the health of their organization, right? How do they determine, if their org is healthy, right? How do I make it easy for them to understand, right? For example, if something misses, a delivery misses, is it a fluke or is it something more sinister, right? Is the health of engineering healthy right now because of some data they got from surveys, but it could quickly change overnight, right? How do they get this information real time? The second thing we see for Directors Plus is the alignment of OKRs to, their directs, right? This one's a huge one, right? You're the CTO, you have an OKR from the board, your CEO, your CEO, etc. And you need to translate this to what's actually happening, right? And how do you make sure that aligns with what you need to get done, right? And how can you be actually confident of delivery, right? And this is really hard because we see things like, hey, often the roadmap doesn't translate into something that you can actually see. One example we have is, the top-down business objective is to sell a new product called, say, smart messaging, right? Product calls it SMS V3, right? And then you're in delivery meetings, and then the team that's actually working on it is calling it something like Sprint Project Bahama Mama. And suddenly you're trying to figure out, what does this sprint mean to SMS V3 to what you're trying to deliver, which is smart messaging. And it's really hard, right? It's not always aligned one-to-one. And the worst part is, how do you see all of this real time, right? Everything's moving so fast. Engineering velocity is really high. How do you know if something's wrong and you have to react? Now, moving down to the mid layer, our engineering managers, right? Their challenges, once again, very, very different than my directors, right? The first one is visibility into escalations, right? If they can't do their job and they need, their bosses to help them, when is that coming? And if that does come late, how does that affect their timeline? They need to have truthiness of what their engineers are telling them, right? Are their engineers actually doing what they think they're doing? And lastly, they need process, right? Process to help them and their team do their job. Process is not enough that, that established process is helping them, but that organizational process needs to be standardized, or else they're working in, one language and someone else is doing something completely different, and it's not going to work. It's not going to cross-functionally enable them. And lastly, engineers, right? What do engineers care about? Well, one, their challenge is, can they do their job, right? Are they set up for success, right? They're coming here to write Scala, but suddenly they can't because they're trying to fix a pipeline that's on fire. They can't find the right documentation, so they're spending all their time trying to fix documentation, right? Are they even able to do what they're supposed to be doing? And for their escalations, right, did their boss actually help them? If there's a cross-functional project, are they being represented correctly when they're not there? And lastly, this concept of burnout and whip, right? Are they getting burned out? Is there too much work? Are they becoming a single point of failure? So as you can see, in one engineering organization, you have multiple different problems from different levels. So let's jump into, how does Jellyfish kind of help Iterable? How does it help us this year in some of these problems? Well, the first problem I like to call is called my high-level alignment problem, right? How do I tell if I have a misalignment of resources? So if I'm leading this engineering organization, or I'm leading a vertical, how do I know if the engineers that are in my org are working on what I want them to? And if not, why? Right? I'm assuming they are, right? And if we're not working, we're not aligned, right? Did we cross wires, right? Did, for example, product expect something to be done and they assumed we give them 5 engineers, but in reality, I didn't even give them 5 full-time engineers. This is 5 part-time. 3 are working on some other project that's necessary, right? Did that cause problems, right? And then how do I know if something's trending unhealthy, right? What happens if things are starting to fall apart? How do I tell? So let's dive into Jellyfish, right? One of the things that I really love about Jellyfish is this kind of concept of high-level alignment. It tells you right away where your resources are kind of deployed, into broader categories. We also use a customized version of this where we have our own defined categories. For example, product development, COGS, security, bugs/incidents, developer productivity, etc. In utilizing this view, we can immediately debug things, right? Like we can tell if the cost of something is too high, right? For example, if we budgeted X% a quarter to fight bugs or incidents, and that's just skyrocketed, right? Now I know where my engineers are going, right? We could tell if certain initiatives are overrunning, right? So for example, we have we're going to do a pen test, and we committed so many engineers at certain percent to be fixing these penetration tests, but it's costly now. Now I'm losing more engineers than I actually realized working on this project, right? And lastly, how do we better enable certain projects for engineers, right? Like for example, we often hear engineers say we don't prioritize technical debt or security initiatives, right? Now we can tell, did we actually budget for this or not? So if you remember, I brought up engineering operations works in kind of a cycle, right? So one, we identify the problem. Two, we kind of hypothesize how to fix it, which is where Jellyfish comes in. So how do we actually drive improvements for high-level alignment utilizing Jellyfish, right? Well, in this case, right, we can see if we budgeted X% for, say, on call, fixing incidents, fixing bugs, and it's exceeding that, we may need to spend resources to pay down that debt, right? If we need to prioritize certain action items, from some kind of incident management, right? Then we can say, okay, this is weighed against our product development. Let's make that change so that we can eventually be more on time on delivery, right? And we can also assign leaders to kind of be responsible for tackling these things. So we can say, hey, look, here's the area we're worried about. We expect this to be improved. Now, initiatives, like I mentioned, you need to be able to review it, right? You need to be reviewing if these initiatives are actually improving. So the component of this is, before quarterly planning happens, right? We have a quarterly engineering review looking at these high-level alignments and saying, hey, this is my expectation. We see this part is eating into this part. I want to increase this so we can decrease this. So this way, next quarter we have more bandwidth. So this bleeds into quarterly planning, and we really use this data to kind of help us plan. The second thing is, we have this concept of biweekly operational review. And the expectation is if we make the plan to adjust our, allocations, we should see this actually happening. And in our operational reviews, if we don't see it, the question becomes, hey, which leader was in charge of this? Why aren't we seeing what we expect to see? Why isn't that changing? Now, moving on to our second, big problem, right? High-level delivery problems. And this is what I call the age-old problem, right? Are we actually going to deliver on time? This is, really, really difficult, if you have hard deliverables, AKA you have a conference and, your CTO is like, we're going to have this great summer release and you better have it ready, right? Or you have a contractual obligation and, you have to hit that date. And this is really dangerous because if you find out a week before, oh, it's not ready yet, now you have to death march to deliver, and that's never healthy, right? The other problem about high-level delivery is you make plans, but escalations and changes happen, right? And if they come very late and mess things up, how do you quantify this or understand the impact of that change? And lastly, if something is at risk or blocked, what does that really mean? Sometimes we see like, hey, something slips by a few weeks, it's no big deal. But what if it's not? How do you tell? So those are real kind of high-level delivery problems we see here at Iterable. And how do we kind of debug this with Jellyfish? So, one of the things that we really love is kind of this view of, your high-level delivery. We utilize Jira initiatives. So for each big initiative, for each team, multiple teams that are contributing to it. We have one high-level enduring initiative, and then each ones have their own epics, and then each of those epics have tasks and then stories, etc., etc. Right? So this really allows us to kind of investigate into divergent views on deliverables. If we say we're going to do something and we expect it to be 50% done and it's not at this point in the milestones, then that gives us a good sanity check that something is wrong, right? And the truth is, in general, if something seems really behind, they're not going to magically make it. Humans cannot just spawn 5 times and just 5 times X, right? It's probably you're going to have problems in delivery. So how do we drive improvements from high-level delivery? Well, we want to be able to double click onto the project and find the source of truth. And I think that's one of the powers of Jellyfish, is that you can literally click on the initiative, click on the team, click on the epic, and you can really see data onto what happens, right? What happens if something is not trending correctly? Let's find out, right? You can click the project, see the resources, and kind of ask your question, does this match what we're expecting? Did something not get worked on? Did something new come in, right? Two, calculate, trade-offs for resources, right? Knowing how much we got done versus how many FTEs can we move around? Can we maybe add someone? Can we maybe, cut scope? Like, what does this really mean, right? And once we do this, can we start to see improvements in time and date? Now, this is really, really kind of like we're eyeballing it right now, which is kind of funny because I believe Scenario Explorer is coming out from Jellyfish, and we're really excited to use that because apparently it just kind of does it for us, right? But right now, the expectation is managers and product managers can kind of eyeball this high level and kind of figure it out. Now, when do we review this data, right? So, the expectation is, we have a all engineering scrum of scrums where we kind of review our deliverables per week and what's red, what's orange, what's green. And this is a great way for us to correlate, yes, this is a red or this is orange and what we should do, right? And then in our biweekly optional reviews, we kind of always look at high-level deliveries in terms of on time and not. And this gives kind of signal both to my directors plus and to my engineers, that engineering managers, that something needs to be looked at and we need to kind of make action. The third category, going down one more, is kind of in the manager space, right? Team level delivery problems. And this one's a little bit different than high level because team level delivery problems usually occur at the SDLC stage, right? That means that as your team is in the SDLC, right, the ideation, the discovery, the scope, the prioritization, your analysis design, all the way to your testing, development, deployment, maintaining stage, is something broken in how your team moves through this SDLC, right? Is there some kind of dysfunction, right? Is it maybe a product management and you have bad requirements making you have to rescope all the time? Is it maybe prioritization is wrong during quarterly planning, so you have to start and stop unexpectedly because you're just working on too many things? Or is there development issues, right? Maybe you're just introducing too many bugs because you don't have a good quality process, right? Or is your deployment pipeline inefficient, causing it really hard for your engineers to even ship anything? And, if your estimations are off, right, it could be very, very clear that something in the SDLC is broken. And if that's the case, no matter what you estimate, you're never going to deliver on time because it's impossible. There's too many variables, right? So, in this case, right, we really want to be able to kind of investigate where in the SDLC is it broken, and then how do we kind of get there? So how does Jellyfish help us? I mentioned, high-level delivery pages. The way we break it up in Iterable is we have the engineering org, and then each org has their own like sub-orgs, right? So for example, AI, ML platform, data platform, product engineering, et cetera, has their own kind of verticals. And each of these verticals has each individual teams inside of it. So for each team, they have their own delivery page, and the managers and product managers can review this, right? And they have this dashboard with each high-level project listed and each task rolled in. So they can easily see something like, hey, why did we miss this, right? Was the scope and effort wrong? Did we just miscalculate our resources? There's not enough engineers, they're on vacation, they're on paternity, we forgot. Maybe someone's not actually working that they should be working on it, right? And then we can actually see, hey, this epic was supposed to be started, but it wasn't started. Why is that? So how do we kind of drive improvements in the team delivery area, right? It could be pretty clear looking at the data when went wrong, right? We see things like, hey, there's new tickets that we had to drop in, that are rescope, that kind of changed things. There could have been disruptions in the project, aka people got pulled off, people quit. We're just terrible at planning, right? Like half the team went on vacation. Or, very well, like someone wasn't working on something and didn't deliver. Looking at this data, we can actually readjust our delivery, right? Because we can kind of make tactical plans based off this, right? And then it also allows us to make escalations quicker. We can say something like, hey, if we don't get help here, we're not going to deliver. Or, oh, if you rescope one more time, that's going to cause us to miss by this many days. And the expectation for us here is that, in your weekly Scrum meetings, we're reviewing this, right? The individual sprint meetings, and when product managers and engineering managers are syncing together, they're looking at this data so they can make the right trade-offs. Now, my last kind of level is my engineers, right? Engineering efficiency and effectiveness problems, right? And in general, engineers just want to do their job, right? They really want to, but if they can't, I kind of bucket into two categories why they're not able to do their job, right? One is they're blocked, right? Their PRs aren't getting reviewed, right? The pipeline is broken. There's some crazy technical debt that makes it really, really hard to get anything done. Or they're just wrong priorities. They're just not working on what you want them to work on because they're being pulled off something else. The second category is they don't know and they can't get help, right? The documentation is atrocious. The code is too complex and they're just struggling. Or they have no support from senior technical leadership in kind of pairing, mentorship, and help. So when any of these things happen, right, how can they flag for help? How can they how raise their hand and you can investigate, right? And also this concept of burnout, right? When they're working and they're doing too much by themselves and they become a single point of failure, right? They could easily burn out or they can quit, right? And then it causes a cascading failure because now other people are taking on that work and they may not even be prepared to do it. So how do we use Jellyfish to kind of help us in this kind of arena, right? So we use kind of the metrics that Jellyfish gives us, and it really kind of helps us determine kind of two categories, what we call effectiveness and what we call efficiency. So for effectiveness, we look at things like PR merge, which is the median count of PRs merged per week. If this drops, it gives us some kind of indication that maybe something's blocking them, right? We also look at things like coding days, and I think it's been renamed to days with commits, right? But if this is lower than average, we can look into why, right? If it's too high, we can be worried that there might be burnout. That's a flag, right? So keep in mind, at Iterable, we don't expect every engineer to be coding every day. In fact, there are some engineers that are, say, seniors. We don't want them to be coding. They should be doing design. They should be doing mentorship. They should be doing other work, right? But we have a good baseline of what is healthy and what is not healthy. And if it skews one way or the other, that's a really good time for us to look into what's occurring, right? Now, I mentioned the efficiency side. These are like PR cycle time, which is the median time it lasts between opening and merging a pull request. This indicates on how quickly software can be delivered to our customers, right? So the lower the cycle time also means generally higher stability because it shows us, how quickly we can respond to issues. This is a good success metrics we want to hold, right? We also look at PR reviews, which is the median count of pull requests reviewed, PR comments, the median count of comments, and our PR pass rate, which is the proportion of reviews resulting in approval of other pull requests. These are what we call activity metrics, right? And they give us kind of this feeling if things are working versus something is not, right? So we can kind of have an idea of, hey, we see things trending the wrong way, that's danger. So how do we kind of drive improvements, right? So we really look at this data, and if we see something trending wrong, we kind of identify areas for enablement or new processes, right? For example, teams aren't reviewing PRs. How do we kind of create a process that kind of balances it out? If we see someone that's kind of burning out or, single point of failure, we want to work with those managers to make sure that, hey, can we give them more resources? Can we deprioritize something? How do we look at this, right? And it also kind of helps us identify candidates for better coaching. If we see some engineers really struggling, why are they struggling, right? Why aren't they able to do their job, right? Is it they just need help? They need more mentorship? What's going on there? And we really want to look at this kind of weekly, right? We have like engineering leadership meetings where we kind of look at these trends and the teams look at themselves.